Right, this is slide 5 of dot product. We will now try to prove the component form of the dot product. Given u dot v, the component form is simply the multiplications of u component for index I multiplied by v components of index I and sum for I equals to 1 to n if u and v belongs to Rn. To derive this component form, we have to review first the law of cosine. Given a triangle that is not right angle, we can have a formula that says the length C square is equals to 1 length A square plus length B square minus 2 times AB, the length, cosine gamma, where gamma is the angle facing the side of the triangle that we are interested in. We now plug in the law of cosine for this side, P to Q. The vector PQ is the side of the triangle that we are interested in, and this side of the triangle is being looked at by theta, the angle between U and V. Hence, a direct application of this is we are looking at the side of this triangle P to Q is length square is equals to one side of the triangle U squared, the other side norm V squared minus 2 times the norm of U times the norm of V cosine theta. This is simply the direct application of law of cosine in this triangle. In the next step, we simply move this side and exchange it to the other side of the equation, and now we have the following, where we have substituted PQ to be PQ is the vector from V minus U, because if we write it in the other form, U plus PQ will be equals to V. Now the half on the right hand side is due to these two, and finally we see that this equation norm of U times norm of V cosine theta is exactly the definition of U dot V. We then expand the calculation of norm of U into its component form, which is simply the individual component square. Similarly, for V square, the norm of V square, we can establish it in the component form. And lastly, V minus U, which is the vector P to Q, can be written also in the component form such as this. Now, if we expand this equation, V1 minus U1 square is equals to V1 square plus U1 square minus 2V1 U1. And this is the same for V2 minus U2, V3 minus U3. Hence, when we plug in all this expanded form into the original equation U dot V, we would get the component form of the dot product. So we have demonstrated for R3 in this example, and similarly it could have been done for R2, and we see this pattern, and therefore the definition of the inner product or the dot product is made.